All right, it is 11 o'clock California time. I'm going to get started on this webinar. So, greetings. This is Craig Adams from California Lightworks. We're really glad you guys are joining us. If you're not able to watch this directly, we'll be emailing this out, recorded version to everybody who signed up. So, just a little background: California Lightworks is a LED grow light manufacturer. We started way back in 2008, so we're one of the pioneers in LED grow lights. We have our own factories in Los Angeles, and we've kind of ridden along with the cannabis industry ever since the beginning. So we'd like to share with you some of our latest technology, especially the new MegaDrive system and uh, our continuing efforts to replace HPS in favor of LED. So I'm also here with Rob Smith. He's Director of Cultivation at Grow Ohio. You want to introduce yourself, Rob?
Sure, Greg. Thanks. I'm Rob Smith. I'm Director of Cultivation at Grow Ohio. We're located about an hour outside of Columbus in Zanesville, Ohio. I'm a systems engineer by trade and an agricultural controlled environment specialist with 10 years of growing experience. I've grown using LEDs since 2013. I've been in the industry since 2015. Before this, I worked in the Colorado recreational market. I helped build the largest indoor grow in the U.S., won some cannabis cups with these teams, and grown about 1 million indoor plants and continue to work with companies through my consulting firm. And a little bit about me.
All right. Well, we really appreciate you joining us. We did a test grow in their facility, which is currently was all HPS, and we did a side-by-side test using our LEDs, and we'll share that test with you shortly. So first of all, here's the agenda, the points I want to cover today. Number one, the current state of the art as far as LEDs and HPS and grow lights in general. Then we want to go into a little more detail about the arguments between HPS and LED. Then I want to share with you an ROI, return on investment, or running expense calculator that we can really see what are the real costs of using HPS or using LED, where we can combine the fixture costs, the electricity, the heat savings, etc. Then we'll go into detail on Rob's grow operation and the case study with Grow Ohio. Then I'll go into a little bit more detail about what's involved in the MegaDrive system. Why is it different? Why is it better than other LED solutions? Then I want to introduce you to a test program, which any qualified grower can do a test similar to what Rob has done to really see what kind of results you can get with this new system. And then finally, we'll open it up to question and answers and hope we can answer anything you might wonder about all the points in this presentation. So first of all, 2021, LED has finally overtaken HPS as the most popular grow light option. Ever since we started in 2008, we've really been battling to push LED to the front. We've always been a big proponent of the technology, the efficiency is involved, the control of the spectrum, but traditionally HPS was so much cheaper, where fixtures might be 5 or even 10 times more than an HPS fixture. And the efficiency rate really wasn't that different. In some cases, HPS was even more efficient in those early days, but times have really changed. So this is a survey from Cannabis Business Times. 2015, only a fifth of cultivators who reported using LED lights in propagation, and LEDs were very rarely used for vegetative or the flowering stage. Since then, LEDs have become the most prominently used lights for every single stage, transforming LEDs from a somewhat fringe interest to a preferred lighting technology for the majority of growers. And here you can see of the people who responded, huge gain in acceptance of LEDs. We're now, for propagation, for veg, for flowering, LEDs actually are the most popular, with more than 50% of growers reporting now they're using LEDs. So this is a huge change for us. This is the first time that we can say that LEDs have really become the dominant technology. So obviously applications in greenhouse, applications in single level indoor, applications in multi-level indoor have really all been taken over by LEDs. But of course, with almost 50% of growers still using HPS, we have holdouts. And one of the points of this webinar is to kind of examine that decision and see if it's really viable to continue going with HPS in the future, especially for new facilities, or what does it look like in making that decision to replace HPS, like the exercise that Grow Ohio went through. So, traditionally there's been two big barriers about LED grow lights. Number one, obviously the high fixture cost compared to HPS or other bulb-based technologies, and kind of a lingering fear that you can't really get the same yield out of LED that you can from HPS. So I want to dive into these things a little deeper. If we look at kind of the pros and cons, like I just mentioned, HPS pros, definitely low fixture costs initially, proven bloom results with a lot of people with a lot of experience flowering with HPS. The cons that we all know pretty well as well as very high power usage, very high heat output, expensive bulb changes, and a fixed spectrum. The advantages on the LED side, of course, we have much lower power usage, lower heat output, little or no maintenance, and adjustable spectrum rather than a fixed spectrum. But once again, we have that barrier of the high initial fixture cost and the fear that you won't get the same yield. So if we look at those primary criteria, first in energy efficiency, we call that efficacy, and it's measured in micromoles per joule. It's a little bit like lumens per watt, but it's more associated with plant growing lights. So when we first started, the single-ended HPS were about 0.9 or 1 micromole per joule. And at that time, our LEDs weren't much better. They were about 1 micromole per joule. Then when they came in with double enders, that really upped their efficiency, where we got all the way up to as much as 1.9 micromoles per joule with a double ender HPS bulb. But every year since then, the efficiency of LEDs continues to climb. Right now, we're up to 3.54 micromoles per joule. So you're really talking about over 40% more light than the most efficient HPS. And this keeps going up every year. We already expect to get over 4.0 maybe sometime next year. So we're really getting over to twice the amount of light for the same amount of electricity. So it's really, that's the biggest reason to abandon HPS, which every other industry, commercial lighting, stadium lighting, high bay lighting, have all abandoned any bulb technologies for LEDs. It's finally happening in cultivation. Heat, it's even more dramatic, up to 60% less heat for the same light level. Apples to apples comparison, you've got much less heat to generate the same level of light. Then we have lifetime of the fixtures or the bulbs. The latest generation lifetime ratings for LEDs that we make, it's up to 100,000 hours. That's with no maintenance. That's with no drop in intensity, no shift in spectrum. An HPS bulb is rated at about 10,000 hours, but in reality, you need to change every 3,000 to 3,500 hours, because as soon as the pressure drops in a high pressure sodium bulb, the intensity goes down and the spectrum shifts from red more towards the yellow, and it dramatically reduces the yield. So a brand new HPS bulb, it's great spectrum for bloom. It's heavy red, it's high intensity, but you quickly lose that over time. So you need to change the bulbs, which is quite expensive over time. And finally, with spectrum, like I said, HPS has been a great spectrum for bloom, especially very high red and deep red, especially very little blue, which is what you want in a flowering light. However, it's never been a good veg light. And also you lose that nice spectrum as soon as the bulb starts to age. With LEDs, we can duplicate the exact spectrum of an HPS. We can duplicate the spectrum of MH or fluorescent, whatever we want. And more advanced fixtures can even give you variable spectrum, which you can switch from a veg mode to a flower mode, automatically adjust the intensity automatically. So you have, these are strong arguments against HPS going forward. Now, I just want to share with you briefly, this is a return on investment calculator. Here we're comparing a 1,000-watt double-ender HPS to one of our 400-watt MegaDrive linear fixtures. So we'll send this out along with the recorded webinar so you can actually play with yourself. These are the inputs. So here we picked a room for 5,000 square feet, just an example. Convert that to square meters, it's 465. Basically, we're saying, all right, we want an average light level, the PPFD of 1,000, and you can plug in whatever numbers you want. We said, all right, we want 1,000 micromoles par reading for both the LED and the HPS. Then the wattage per fixture, an HPS in real life is about 800 watts by the time you add the inefficiency of the ballast, et cetera. Our MegaDrive linear fixture runs at about 380 watts. Obviously, you need 2 of the 400 watt LED fixtures to equal that light output. So we're really figuring kind of a 2-to-1 ratio on the fixtures. There again, as we discussed, efficiency, there's no contest. It's almost 70% more efficient than HPS as far as how much light for how much power. Once again, heat, we're over 60% less heat for the same light ratings. We also have we're using average costs. But there again, you can plug in anything you want. We're saying, okay, you can get a decent double-ender 1,000-watt for $350. An average price and volume for our MegaDrive 400 fixture is $500. So yeah, you have definitely more than twice the price on the fixture cost. Big factor for us is utility rebates. Around the country, we've been getting an average of up to 25% discount on the fixture so that people won't use HPS. Obviously, that varies by state and your situation, so we just have that input at 0. So our net fixture costs $350 and $500. We're assuming a decent double-ender HPS bulb will cost around $50. We're saying that might cost around $5 to actually change it. We're going to run these in flour 12 hours a day, and we make an assumption about electrical costs, which is 15 cents per kilowatt hour. Obviously, you can plug in whatever number is your real electricity cost. We also have a number in here for installation fixture cost. With an HPS fixture, you need 1 power drop per fixture. So that means electrician time. You also have to mount it. So we're assuming about $150 to install in a new facility per HPS light. MegaDrive doesn't have power drops. I'll get to that later. So we're putting about $20 per light fixture. So you can see the kind of advantages of up to almost 90% less installation costs as well. What we get out of that, then we get a clear annual operating cost when we're all in on power, fixture costs, electrical usage, bulb changes. We can see that on this average, we're averaging over $140,000 cost savings per month. Even in the first month where we have to pay that big premium for the LED fixtures, the difference is so big is that you start saving money right at first year. And here we can calculate the payback period. So under this example, in 8 months, you've paid for the LEDs. Now, every moment after 8 months, you will have lower costs with the LEDs up until that 100,000 hour lifespan. So what that looks like on a chart, here we just spread it out for 5 years. Like I'd say, the LEDs in blue, even the first year, when we've paid almost 3 times the price for the fixture, we're still ahead because the energy savings are so extreme. And it just gets better every year. So this is the biggest argument, that if you're running a commercial operation and your goal is return on investment, I can't see why anyone would go with HPS when you see numbers like this. So at this point, I want to let Rob take this over. We met Grow Ohio about 1.5 years ago, and they're all HPS. Rob can kind of give you the details of their operation. They wanted to test, first thing they wanted to do was test 4 different types of LEDs in one of the rooms and give them kind of equal footing, see which one of the LEDs did the best. So we did a 4-way head-to-head grow comparison. There was Gavita, Grower's Choice, and a Photo Bio fixtures. And basically, and then the MegaDrive 400, basically we blew the others away. So they decided, all right, we want to expand this out to a full room test to really do a comparison using a similar strain, similar layout and everything. And from there, I'll let you take this over, Rob.
All right, sounds good. Thanks, Greg. Yeah, at Grow Ohio, we're 20,000 square foot of canopy, 20 flower rooms, 4 veg rooms, mother prop. We currently use the double-ended HPS. We're looking to make major shifts in the facility, update our fertigation, our controls. We'll be switching to living soil pretty soon, and we want to keep up with that with our lighting as well. But yeah, the trial's doing really well. What we've seen the most benefit was obviously was the electrical consumption. We noticed 50% reduction on the light, 45% reduction on our HVAC. Our yields were comparable. We had the trial that we ran, it was the 4th highest yielding from that strain that we'd ever had. We're consistently getting 100 grams per square feet. We're really looking for a little bit more than that, but we're happy with those results. Terp profile was the same. We did see a little bit gain on our Delta 9 THC. So yeah, all in all, really good results. I've been really happy with them.
And here's a basic summary that we took from your results. So each room was 642 square feet, same number of plants, same strain, which is a triple chocolate cake. The only difference was the lighting. So it was 72 of our MegaDrive 400 fixtures versus 36 of the HPS double ender. So on this particular strain in this run, if we look at grams per watt, it's a huge advantage. Obviously, we're much more electrically efficient, so you're getting much higher yield for the amount of electricity. Then even on the square footage, grams per square foot, we out yielded HPS. So we're really happy with these results. We think we could even do better. But as he said, with the savings in electricity usage, this will pay for itself in a couple harvests, basically. So we just think this is the most concrete example. We can match or improve the yield. We can run at about half the electricity, about half of the heating, with no maintenance, no bulb changes, and a very, very long lifespan without having to do any changes to the fixtures. So next, I want to talk about this new MegaDrive system, which is quite different than traditional LED systems. What we've done basically, we have taken the individual driver out of the fixture. A lot of LED fixtures have a drivers built in, or they'll have a separate driver mounted separately for each fixtures. We've removed those and consolidated those into one large power supply. The driver is about 30% of the fixture cost. So it's an important way we can save money on a fixture with the same light output, with the same LEDs, just lower fixture costs. Then if we consolidate those into a central power supply, we can run up to 27 of these 400 watt fixtures on a single power drive. So we have some really important advantages in installation, especially. So we eliminate the drivers in each fixture, dramatically simplifies the electrical infrastructure and installation, eliminates contactor panels. So we can shut these off with digital controllers. So now you eliminate any power drops over the canopy, which is a huge savings in electrical charges. We eliminate the contactor panel on the electrical panel, which are also very expensive. We have the highest efficiency ratings of any LEDs in the industry. We get better efficiencies through this central driver than we do with individual drivers. Plus, these are two-channel digital spectrum control, so we can vary the spectrum between veg, bloom, propagation, final finishing. And also in a greenhouse, it'll even combine with a photo sensor to automatically raise and dim the lights. So here again, we can do up to 27 400 watt fixtures run from a central power supply. That power supply doesn't even need to be in the room. That can be mounted on an outside hallway, in Grow, Ohio, they put the power supplies on the roof. So there's no power supplies in the grow room at all. This saves additional, less heat, much easier to service. All the electronics are in the central power supply. So any repairs, you just swap out the power supply. It takes 5 minutes. There again, we have 2-channel spectrum control. There's a white only channel where you get a high level of blue, and then a red only channel with deep red at 60 nanometers. That's really the key driver of photosynthesis in flower for cannabis. It's that deep red. However, blue is a fundamental spectrum to use in veg, especially if you want to avoid stretching, get nice bushy plants, lower spacing between the nodes. However, too much blue in flower actually reduces yield. So with this system, you can reduce the blue, max out the red when you're in flower. You can back off the red, which tends to induce stretching, maximize the blue when you're in veg or propagation. Also, even in final finishing, blue seems to be the main driver of chemical profiles, especially terpenes, THC, CBD levels. So once you've got your yield in the last week or so, week or two, you actually can back off the red and really push that blue light level for better chemical results. We also give you multiple control options. This system will work with Bluetooth. We have our own Bluetooth app. You can control them wirelessly with any Bluetooth device. We also have a hardwired touchscreen controller. This is what we use in Grow, Ohio. Basically gives you ability to program, save up to 20 strains. You can have separate routines for every day of the grow. You can start with early veg propagation, go through a veg cycle. You can automatically shift from veg to flower with a progressive rather than all at once. You can slowly transition from veg to flower, which is much more like it happens in nature. So you get a much quicker changeover. You don't get that. The plants get a little bit stunned when you all of a sudden go from 18 to 12 hours. This can do that gradually. You can also do final finishing modes. So you can save different strains that might have different veg times or different flower times. All fully automated. You can run an unlimited number of lights from one controller. They daisy chain to all of the power supplies. Then, especially in a greenhouse, we can link up with any third-party greenhouse controllers, wired directly to their controllers. Then you can run those programs with your environmental controller, use their photosensor to adjust light levels. So very flexible control options for pretty much any type of installation. So just to summarize, we save costs on the fixtures by pulling the drivers out. Huge saving in installation by centralizing that in one power supply. All the electrician has to do is do one connection at a power panel and then run 27 lights. You just unskilled labor can hang it up. It also works on any voltage from 208 up to 480. Significant cost savings in operating costs due to the high efficiency and the higher efficiency drivers in the central power supply. Plus, with our controller, you can never have more light than you need or less light than you need. There again, spectrum control gives you better quality results, better chemical profiles. So we've done a lot of these installations in greenhouse. Here you can see the power supplies can be mounted on a wall. The cables then will go a whole string of 27 lights, which is a pretty good distance to do a whole run in a typical greenhouse. There you can see, you see no power drops over the canopy at all. There's no electrical. It's just our cables, which we are included in the price. We custom make all these cables depending on your particular light plan. They're all waterproof plugs. The fixtures are waterproof. We can do this in almost any type of configuration. It arrives as a turnkey project with the power supply, the fixtures, the cables, the hanging hardware. You just have to have an electrician connect the power panel and you're ready to go. These make it really flexible. If you can add lights, you can take away lights. You move facilities, you can take the lights very quickly. There's nothing to rewire. So very flexible system. We're also doing this a lot with single level HPS replacement. There again, this is the Grow Ohio example where once again, you don't need any power drops over the canopy at all. You can see that their old HPS plugs are just dangling. They could put the power supply in the roof, on the outside in the wall. You can have the controller mounted just outside the grow room. It'll track everything. Then finally, multi-level. If you have a high ceiling with a high space between the shelves, we can use the linear fixture on multi-level. This is another example. We have a case study video on our website where they're replacing single level 1,000-watt HPS with double level linear MegaDrive fixtures. We also have a new spider style fixture that also works with a MegaDrive. So that's for much lower shelves or low ceiling applications where you can't get the lights high enough. So it really offers you solution for any type of application now. The spider fixtures coming out towards the end of the year should be available shortly. There again, in almost all cases, we've been able to out yield HPS. As long as we have the same light level, we usually do better because our spectrum's better. HPS has a lot of wasted spectrum in the yellow and greens, which are not as efficient in driving photosynthesis, especially in flower. We've also been pretty consistently beating other LED manufacturers on head-to-head with the same power and everything equal. That's because we have a high ratio of red, which is specifically for flowering in cannabis. That's really where we get the difference. And then we can adjust that to whatever phase the plant happens to be in. So it's incredibly efficient, very effective, cost effective as well. So we're pretty happy with how this comes out. One thing we're offering, and you can contact us about this after the webinar, we're offering a test program. Take us for a test drive. It's no obligation. This is a little bit what we did with Grow Ohio. That's a good example. What we're willing to do one power supply and up to 27 fixtures at a no-cost basis for qualified growers. You can install that. You use it for 90 days. At the end of 90 days, you can return it, 100% refund of any expenses. So it's really a no-cost offer. Or you can have the ability to keep those test lights at a reduced price, at about half price of what the normal list cost is. This is mainly because nobody's ever returned one of these. We know the results are incredible, and we want to get these out there to as many growers as possible. Obviously, there's certain minimums, and this is for larger scale operations. But just email me after this if you'd like to get more details. You can discuss it with a salesman. Also, we can do free light plans if you're thinking about switching from HPS and you're wondering about the details, how many fixtures would you need, what the light levels will be. We can do a very detailed light plan, no charge, no obligation. We're happy to do this. We can even do an energy analysis to how much you might save with this type of LED system. So just reach out to us and we can get you in touch with the proper salesperson and our lighting designers. With that, I think we've covered most everything. And with that, I would like to open it up to any questions. And I'm looking through the chat room here. His first question is, during the test of the different light models, I assume the light intensities were measured, but we didn't show this in the presentation. Rob, did you guys do any measuring of the actual PPFD levels or PAR levels after the lights were installed?
We did, and we just try to keep our flower at about 1,000 ppfd.
So it was pretty close to the light plan model, the target light level we were trying to hit?
Correct.
Which was around 1,000?
Yep. Another
question is, 480 volt or 277 volt, the best voltage is 480 three-phase. That uses the best, most efficient power from the power supply. But we can do 277, we can do 240, we can do 280 three-phase, we can do 208 three-phase. It runs pretty much the same way on any voltage. It's a little bit more efficient on 480 Three-phase, because if you're doing 480, you can run one power supply and 27 fixtures at only 12 and a half amps. So it's super low consumption, a minimal amount of breakers. Obviously, you have to use higher breakers for the lower voltages. Let me look at some of these others. Good question. With lower wattage, I hear guys running have to add heat in the room. Is that right? That's a really good point, because there's, number one, there's a strong relationship between heat, temperature in the room, and humidity. The higher the temperature, the more water can be suspended in the air. The colder, the less water can be suspended in the air. So actually, HPS heat is an advantage in that case, because you'll have more water suspended in the air. You'll have less condensations on the plant. The dew point is much higher. Also, the infrared heat from HPS is very intense. You can feel that with your hand. It's direct infrared heat, which causes a plant to transpire a lot from the leaves just to keep themselves cool. And what happens then is that their uptake of nutrients and water is accelerated due to that infrared on the leaves. You don't get that with LEDs. You don't have a high infrared output. The heat comes mostly off the back of the LEDs, so the heat is much less direct on the plant leaves. They will also run much cooler, so your grow room will be much cooler than you're used to, and that's what Rob is saying. They pretty much use half the AC to maintain the same temperature level. What we suggest with LEDs, run them hotter. You can accomplish the same thing that HPS does by running your room about 10% higher. If you're generally running at 75, you're ready to go up to about 85 with LEDs. Then you get that same effect of the high water suspension in the air, also the higher uptake of nutrients in water. But that's a really good point, because if you run the room cooler, you'll definitely have more humidity and less nutrient uptake. How long from ordering to shipping? That's another good question. Right now, we have our own factory in LA. We make everything here. We don't bring things in from China. So generally, it depends on the size of the order, right? I mean, we have some projects that are 10,000 lights. Obviously, those are spread over several months. They can't even install those all the time. But the shipping time is usually 4 weeks or less from confirmation of the order. Depends on the time of the year, et cetera. But right now we're running 3 to 4 weeks, so it's pretty fast. Okay, in a greenhouse grow, how are perimeter zones controlled off a single daisy chain of fixtures and one driver? The way the MegaDrive set up is each power supply is one zone. So you can't get smaller than a 27 light zone. Also, 27 lights is the max. You can do as few as 12 lights. So that's kind of the range. So each zone is one power supply. So that zone could be 12 to 27 lights. You can control that zone independently. So let's say in a greenhouse, you have one side of the greenhouse that's usually in the shade in the morning. You can make that one power supply. It can run on its own photosensor to go off even earlier than the other lights because it's in the shade. You can do the same thing at the other end of the greenhouse where you might have shade in the afternoon. You can make that a zone to operate on a separate photosensor. Also, if you have a greenhouse or a grow room with multiple houses that are on different cycles, you can make each house a zone and have that timer specifically have the spectrum set for what phase those plants are in. But you are limited to a minimum of 12 lights per zone, so you can't get any more detailed control than that. What were the results between Gavita, Nextlight, et cetera? I don't have the exact figures from Grow Ohio. It's in our video. There's a Grow Ohio test video, and I believe they tested them against the Gavita, but not the Spider fixture. It's their new HPS replacement LED. There were a Grower's Choice Spider style. There was a PhotoBio Spider style light and a Grower's Choice spider style light. Number one, the worst performing was the Gavita LED HPS replacement. Really didn't yield at all, according to them. The three spider lights did pretty well, more or less on an equal level, but much less than the MegaDrive. And that's one point that I'm a strong believer in. If you have a higher ceiling, that doesn't make sense, and you're on single level, it doesn't make sense to use a spider style light. You get way less penetration into the canopy. You get much less intensity. You get less overlap from multiple lights. You get less reflection from the walls. We will out yield any spider style light as long as we've got enough clearance over the top of the canopy. We'll out yield them 20-25%. Hands down, and I don't care whose spider light it is. Now, obviously, if you're on a shelf with limited overhead space between the shelves, or if you have a low ceiling, like an 8-foot ceiling or a 7-foot ceiling, you're going to be better off with that spider style light because it can get closer to the plant. It spreads the light better. You'll probably get some light burn and hot spots with the linear style. So that's really the application for a spider style light. And like I say, we have our spider version in testing right now with a lot of growers. But if you have the clearance, a linear fixture or a high bay fixture will definitely out yield any spider style light. And that's a great question. And does it use 3-phase for all the 480 volts? Yes. We can do single phase or 3-phase. When it runs on 3-phase, it uses all 3 phases. Who makes our chips? Osram. We've been 100% Osram factory since 2008, and we haven't found any improvement over those, although we do test Cree and Samsung and everybody all the time. Osram has been phenomenal, really, especially their reds. Their deep reds are by far the most efficient in the industry. And for our money, that's what drives cannabis yield. And you can't beat those deep red Osrams. Difference in quality, lab test, THC, HPS. You were just talking about that, Rob. What did you find in general in that first test?
What we found was Delta 9 THC. Our original was 7.7 milligrams a gram, and we went up to 11.1. So significant in Delta 9. Everything else was pretty much on par, and nothing really statistically different.
And you didn't run any different spectrums. You pretty much had full blast or even spectrum through the whole test.
Right. Well, HPS were at full blast, and your fixtures were running at only 80%. So
80%, both white and red, right?
Correct.
Because, like I say, some people like to finish the last week or two and back off the red and go to deep blue. That's old school growers used to go from HPS to metal halide at the end because you get more potency, more smells, more colors. That is a strategy you could use with these lights. Back off the red at the very end, and more blue saturation should give you a bump in a lot of the chemical profiles. How is your warranty? Our warranty is 5 years. A commercial warranty, it's 5 years, 100% warranty. All of our factory and customer service in LA, so we can do really quick turnarounds. All the fixtures are modular, so even an older fixture 10 years from now, we can repair it, keep it in operation. It's not like a lot of Chinese lights where you pretty much throw it away when the electronics go sour. We keep our lights running for decades. How is your warranty? Say it drops off the ceiling. Like if it drops off the ceiling, we won't warranty that, but we can replace it instantly. We have them in stock. We can do next day service. The beauty of the MegaDrive, if anything, there's only 2 components in the MegaDrive, the fixture or the power supply. Those can be replaced in 5 minutes. Just a replacement, click in the cables, you're done. There's nothing that has to be taken apart. Here's another one. what are your thoughts on UV and adding UV supplemental bars? We were probably the first ones to add UVB fixtures to our lights. So, but first you need to specify between UVA and UVB. UVA is just the end of the purple spectrum, the blue spectrum. And there is some photosynthesis in UVA. Some manufacturers like to add, like you mentioned, Black Dog, they like to add UVA to widen the spectrum for photosynthesis. And there is some benefit. We haven't seen extreme differences by adding UVA. On the other hand, UVB, which is farther into the blue spectrum, UVB, there is no photosynthesis, so there's no additional growth. However, introducing UVB towards the end of the grow, the last 2-3 weeks of flower, will tend to bump up your THC levels. A lot of people don't know this, but cannabis started producing THC as a reaction to UVB in the sun. So all the cannabis strains that are native to the high altitudes or to the equator tend to produce some level of THC, where the ones that are native to the northern or southern hemispheres don't produce THC. That's because of the high UVB in the native origin of these plants. High levels of UVB damage the cannabis plant's reproduction cycle. The seeds will not take. If the UVB passes a certain level, they're very sensitive to it. So in what we call nature's little joke, cannabis evolved this chemical coating which acts as a natural sunglass. It's 100% UV blocker. Whenever it senses a certain level of UVB in the light, it starts to produce more of that chemical, and it actually coats the trichomes as a very efficient UVB filter, and that chemical is THC. So growers who want to get higher potency introduce a supplemental UVB, and we've always sold supplemental UVB fixtures. They're fluorescent though, rather than LED. The fluorescent UVB fixtures are much more powerful, much less expensive. They make UVB LEDs, but they're ridiculously expensive for very low output. But no, we're big believers in UVB in cannabis, which is kind of a unique situation for that plant. Let me see if there's any. Does the MegaDrive have a UV attachment? No, but our UVB fixture, it's a linear fixture, just like the MegaDrive. You can run those in a chain of up to 30 lights off a single power outlet. So those can be run alongside, or let's say if you had a double row of MegaDrive linear fixtures, you run one row of linear UVB fixtures, and it's exactly the same result. So there's not really a need to mount them onto the fixture. You could just mount those separately. Is UVB safe to work under? No, it is not. That's why we warn everybody. UVB is harmful to the skin. It's harmful to your eyes. And too much UVB is harmful to plants. That's why you got to make sure to follow our recommendations as far as how high you hang the UVB lights, and never work under them. Always turn them off if you're working under the canopy. Very important, especially if you get close to them. They're quite powerful, so you should never work under UVB lights. And I'm thinking that's the end of the questions. Do you have anything you wanted to add, Rob?
I don't. I got a question for you. HPS lights, obviously the red light's more efficient than the blue. Does that translate in the LED world?
Oh, yes. Each color in the spectrum has a different efficiency. So as you go into the reds, the micromoles per joule are much higher just because of the nature of that spectrum, the wavelength of the spectrum. You go more to the blue, the micromoles per joule are much lower. And white is kind of in the middle. White, of course, is not a color. White is a blend of colors. So basically, by far, the most efficient are reds. Deep reds are now getting up to 3.4. They're pushing 4.0 as far as micromoles per joule. Blues are much lower, like in the low twos, 2.2, 2.3. Whites right now are kind of in the 2.7, 2.8, 2.9, kind of in the middle. So obviously you need some white in the spectrum. Plants won't grow under only a red spectrum. But white LEDs are interesting because it starts with a blue diode. So you have a blue LED diode. It's coated with phosphor. And that phosphor is what gives off the photons, similar to how they coat the inside of a fluorescent bulb, for example. So you formulate the phosphor, you coat the LED, and obviously you have a little bit less efficiency because it's transferring from the LED diode to the phosphor. Then how you formulate the phosphor, you can push it a little bit more to the red, you can push it to the blue. In the same way, there's different color temperature fluorescent lights, T5s. That's the mixture of the phosphor coating the LEDs. So it's, it was a huge breakthrough to have a white LED in the first place. They're not as efficient as red and blue as far as photosynthesis, but everybody is adding, even an all white spectrum these days, a lot of grow light manufacturers are adding supplemental red. So you get that balance. You can't beat the deep reds for photosynthesis and yield. Oh, the white is the absence of color. Well, I think absence of color would be black, but you might be right. Asking your fixture uses 12.2 amps. The amps drawn by the MegaDrive power supply will vary with the voltage. Obviously, a relationship between amperage and voltage. The higher voltage, which would be 480 three-phase, that draws 12.5 amps. So it's super efficient. Obviously, if you're running 240, it's going to be twice that, just because of how electricity works. Here's another question. Also, I heard you may have a driver available for single phase. Yes. When we introduced this about 9 months ago, the 480 volt driver could do 27 lights. Then but at 240, it could only do 16. We have a new driver though that's native to 240 coming out in about a month. So now the 240 version does 27 lights as well. So it's equal. So voltage doesn't matter. You won't get penalized for a lower voltage. You'll just have a higher amperage breaker and you'll have to have more amps available at the lower voltage. Somebody says, what's the comparison between MegaDrive and Solar System 1100? They're totally different animals. Solar System 1100 has 3 channels. So you have blue on a separate channel, white and red. So you can do spectrum control between those 3 spectrum. A lot of people like to have the blue channel, especially for indoor, so you can really finish in all blue. That's where you get big boost in your chemical profiles. For the linear fixture, it's 2-channel. Obviously, Solar System has active cooling. It has fans. It has three channel spectrum control. MegaDrive is passive cooling, so there are no fans. There's no moving parts. It's all waterproof, and it has 2-channel where the white has a heavy spike in blue. And you have all the deep red in the other channel, so you can vary that blue-red ratio across 2 channels. So here's a question. If we bought 27 units and the MegaDrive power, what's the cost? The MegaDrive list price, which doesn't mean anything, but the list price is $669 per fixture. That would be at the minimum number of fixtures. And these are like 27, and you can go as low as 12. Although depending on the application, you're talking in the low 600s. In volume, it'll get well under $600. It's heavily volume based. We're doing these are obviously designed for large scale, especially greenhouse, where a single greenhouse might use 3,000 fixtures or 4,000 fixtures. obviously we have volume breaks for that. But even for a small grower, like the spider fixture, you can run as few as 7 lights and as many as 16. On the linear fixture, you can run as few as 12. So it'll even work for smaller grow operations. Let me see if there's anything else here. Is the cost of the fixture included in the MegaDrive power supply? Yeah, all one price includes everything. How do you see cost and fixture trending in the next few years? Well, when we first started this company in 2008, our big challenge was HPS was just so cheap. It was really hard to compete with. So all of our focus has been how can we make LED cheaper? And we look at the dollars per micromole delivered, installed dollars per micromole. We looked at the components. We said, well, the LEDs come from worldwide market, right? So it's hard to compete with that. But where we thought if we pull the driver out, put the electronics and centralize them, we can drastically reduce the fixture cost. And that's what MegaDrive system has done. The other major trend, though, is from the LED suppliers, from the diode manufacturers, it's electronics. So every year, the prices get cheaper and the output gets higher. This is what sealed the fate of HPS. The HPS is not moving as far as efficiency. LED, we always talk in terms of micromole per joule. Like I say, the early LEDs were they were under 1. Now we're pushing 4. And in the lab, they're going way beyond 4. So that's already twice as much light as an HPS. And we're not sure where the theoretical limit is, but over the next few years, a lot of people are saying we're going to get up to 4, which is huge. It's so efficient. Power supply and the fixtures are all in one price. It's volume pricing based on how many units are in the network. There's extra charges for the control option, the touchscreen controller or the Bluetooth module add extra, but it's not much. It's like $200, per power supply to add control options. I don't see any other ones. So what would be the selling point for non-industrial growing, say caregivers? And what should I focus on when advertising your product? Well, that's a tough one because these are not things that you put in a box and put out at a retail store, because we have to design the cables. So every installation is a custom installation. It's not that complicated, but we do need to know how long the cables are, how far are the lights apart, and that's what determines the light levels. But like I say, even a medium-sized grower who's got a dozen lights or 16 lights can easily do a MegaDrive system and save a lot of money. It's probably not there yet for a hobby grower who's got less than 12 lights. Although if you're doing on shelves with a spider light, you can go as low as 7 lights. So the lower level is pretty reachable. Obviously, it's not going to be a hobby light to sell in hydroponic stores yet. Here's a question. What is the light space coverage footprint for 1,000 ppfd? In the Grow Ohio, that was our target, 1,000 ppfd, where the 1,000 watt HPS was doing 1,000. 2 of the MegaDrive 400s were doing 1,000. So although if you take the ppf of a 1,000 watt HPS, it's about 1,900 ppf. If you have 2 MegaDrive fixtures, it's 2,200. So you're getting actually more than 10% more light with 2 of our fixtures than 1 single HPS. But that's a good ratio. If you've got a 4x4 or 5x5 under 1,000 watt HPS, you'd use 2 of the linear 400s. And I'll finish this with the last comment. With the biggest takeaways for me for the test: 50% reduction in power consumption and no loss in yield, and that comes from our guest, Rob Smith, who I thank you for working on the test, and thanks for doing the seminar with us. And we wish you all huge harvests and huge yields. Thank you.
Thanks for having me, Craig. I'll try to get these test results over for you and whoever wants to look at them as soon as I can.
Sounds good. We'll send this all out to you in a recorded version along with whatever other materials we can give you. So thanks very much for joining us.